Hello and welcome back to another video of Advent of Code, running on SerenityOS and using the jakt programming language. So I've just done a new day, and last time my input didn't get downloaded, but now it has. My session timed out, so I had to update all my things, and now I'm logged in here. Cool, so day 18, we made it out of whatever cave we're in, and now we're noticing that there's like lava flowing past, and what we need to work out is whether it like makes rocks, I guess, obsidian rocks out of the lava. As it rushes past us, we look at it and see where the lava is, except our resolution is really terrible, and we basically have 1 by 1 pixel cubes. And for the first part, we need to get the total surface area of all the cubes in this graph type thing. So I've got an idea on how I might do this, and I also might do inputs. We can do, so if I do that again, we can do something like that. Just double check, with a hyphen. And here we have another input of 1, 1, 1 and 2, 1, 1. 1, 1, 1 and 2, 1, 1. You missed me put in all the example input in the last video, because I wasn't logged in, so I just killed the video quite early on. But yeah, I had to type in manually because I still haven't gone around to working out why I can't, like, I can sometimes like triple click on it, but this is like a pre-element, and I wonder if we can. No, we can't really change the size of that, but yeah, I might come back to that. So what I want to do, probably open up a hack studio because we're about to do some hacking. Maybe this can go full screen that way, and maybe not quite full screen that way, but maybe over to like there. That kind of goes across quite a bit. Right, so day 18. What I'm thinking is we kind of have two notions. We have a cube, and I'm going to introduce something called a surface. So a surface is a set of cubes. We'll just have it as an array of cubes, but what we can do is we can have a cube, and what this has is a x. We don't actually need that, and z. And here we can have a surface, and here we're going to have a cubes, I guess, and it's going to be an array of cubes. And I guess here we need to have a public function construct, and maybe take in a string. Will be thrown because we'll be generating a thing. Now I think what we want to do is actually take in a cube, but we'll still throws because we're going to be creating a thing, and we'll do that. So here we can, well, in fact, we could potentially just return surface of cubes is an array just with cube in it, and I think the typing will be happy with that. So what we can do is actually do a quick test compile of that. Looks like it's compiling, so I'm happy with that. in the past I've had to like make a variable before and initialize it, but that's because I'm using an empty array. But this time I'm just having a thing. What I also want to do is have a class like a bounding box. I'll just call it a box, I guess, and maybe I will put it there. And what a box is going to have in it is it's going to have a origin, which is going to be a cube, and it's going to have a corner, which is going to be a cube. But I guess it's going to have like 3 dimensions. The idea of this bounding box is I want to see at a glance whether the surface is whether a new cube is contained inside of a surface. Right. What I might do is come back to that and do this because I started typing it. So here we'll be throwing throws, and in this we're going to have basically this input here. So let's split equal split on comma, wasn't it? And here we can return cube. In fact, I wonder if we can do something like this and split. I kind of want to like map it, but yeah, I think I will just do this, but on one line. That's not what I wanted. But that's alright, because I can correct what I want, and then here we can just return cube of x, y, and z. Yeah, so when we're testing whether we're inside of a box, I think I need to draw something maybe, because say we have a grid and say we had a point there and a point there. So this is just a 2D grid, but what we, in fact, let's make it there. I might be overcomplicating it. But basically, in a bounding box in a 2D sense, you would have this corner, and it might not even have anything there. Like, say, if we did something like that. This one here would be one corner, and this one here would be another corner. And when we get a new point, we can basically test whether the x of the point is greater than the x of the corner, and we can test whether the same with the y, but then also test against the other point that's less than, and if that's the case we can see whether it's inside the point. So my thing I'm thinking is we're going to have a let cube equals cube construct and take in this line, and then we're going to have like mute surfaces equals and here we need to say it is type surface and make that an empty thing. And so I guess for s in surfaces we want to see whether if s dot overlapped, maybe I'll call it cube, then we're going to do something, otherwise we're going to else. So what I'm thinking is, looking in the 2D space, say if we got this cube here, it doesn't actually... Yeah, I guess in my kind of surface analogy, we would have a surface that has all connected points, and if, say, we're looking at this point, it would say, yep, I'm connected. But say, I'm just thinking, say if we had that point as well, so we've got one surface up there and one surface there. We look at this point, we see that it's overlapping with this one, so we add it to that surface. But then here, when we might get this point, this actually overlaps with two different surfaces, and we need to like join them together in the way that I'm thinking. So I'm wondering if I just scrap the... let me just have a look at my input again. Input. So my input is quite large. So yeah, like on every point that we read, we can see whether it is inside a potential surface area, and like not check it if it's not, I guess. Yeah. Yeah, I'm wondering how to do a box. Because I kind of want to... the naive approach is every time we read it, we look at all the other cubes that we've had and work out how they overlap. But that's like n squared on like 2000, which like isn't the most optimal. Whereas I was trying to think of, let's break it down into build up the surfaces as we kind of go, and so each surface is a connected bunch of cubes, and we can tell whether a cube possibly is in that region, and if it is, we just add it to that surface. But then we also need to work out if two surfaces would then overlap, or two or more really. Yeah, so we would probably want hardlet function overlaps. That's what we call it, and we're going to take this, and we're going to take a cube, which is a cube, and we're just going to return a bool and maybe panic not to do overlaps. And maybe we can include our panic from helper. And we probably also want the public function join mute this, because we'll be changing it, and we'll also take in a cube, and we'll do that, and panic to do join. And we probably also want an overloaded thing, this, and a surface of type surface, and panic to do join surface. Right, so that's going to be all of that. And so if we overlap a cube, and because yeah, we kind of want a edges class, and that's going to just return us how many there how many edges there are to do edges, how many visible edges there are. Yeah, because our solution is just going to be our edges of every surface. So mute edges equals 0, and we can go for S in surfaces. We can probably do edges plus equal to S dot edges, and then we can print line part 1 can be that one and edges. Right, so there'll be the output of that. So we don't need that. So we kind of need to know what to do when we overlap and how it will kind of update the edges. So I think the edges we will probably have like running total, so we won't like construct it as we go, because every time we add a cube, cube's got 6 sides, so the first time we add a cube, that surface will have a edge of 6. If we then add another cube, it will be touching one of the other cubes in there, so it will basically have 6 for the new cube, but it will take away 2 per thing it's touching. So I think edges, this can just be U size, and maybe it can start at 0. Yeah, and so when we join this cube, yeah, I think public function touches, and maybe take this cube, which is a cube, and it will return a bool. And here we can, if dot x equals cube dot x and dot y equals cube dot y, and ABS, so we need ABS, of dot z minus cube dot z equals 1, we will return true. And we kind of just want to do the same 3 times, but do different things. So maybe this one will do x and z, and then the y is different by 1. And here maybe we can do y and z, and here the x is off by 1. And do I need to do it? So if x and y are the same, and x and z are the same, and y and z are the same, so those are the 3 combinations we do, and then the last one is just always not the one that we've tested. And here we can just return false if we get to that point. So if something touches, so in this join thing, so we're going to have dot edges plus equal to 6 for the new cube, and then for C in dot cubes, if C dot touches this new cube, then we want to go edges minus equal to 2, like that. And then at the end we just want to cubes dot push this new cube, and I think that will be what join of just a cube will do. And this edges, we can probably just return dot edges. Right, so if we overlap, and that's kind of the overlap is something I need to do. If we overlap, we want to go s.join cube and maybe to do check all the other surfaces whether it can join. Yeah, potentially even mute touching equals of type surface array. We can do that, and here we can. I think I'll call that touches, not overlaps, just because that is what we call the cube one up there. So if it does that, then touching.push cube, and here we don't need to do that, and I guess we don't need to do like an else, so we only do it if we're touching, and if touching dot maybe we will do a guard touching dot is empty, and we're guarding that it is not empty, else panic. Actually no, we don't need guard at all, because in this case, so if there were no things touching, we just need to go surfaces dot push and add a new surface, so surface construct and pass in our cube, or like that. Otherwise, we, if touching dot size is greater than 1, then here we need to add to first, then join existing ones. Yeah. Do I still have my little picture? Nah, I don't. Yeah, I'm just thinking forward. Otherwise, what we can do is now, because we're doing classes, it's copied by reference, so we should just be able to go touching 0. Don't need to bang it, and we just want to go join and give our cube. Yeah. So this touches, I guess here we just need to, for C in dot cubes, and if C dot touches cube, then we yeah, then we can just do an early return of, yep, it does touch something here, otherwise we can return false, and that does the touches. So the join surface doesn't exist yet. I guess we could write it up though. So for T in, for I in 1 to touching dot size, in here we want to go touching 0 dot. Can we remove? Yeah, I don't think we can easily. basically check source jakt, because we are looking at a dynamic array, and yeah, we can't like remove from the array, which is frustrating because our other options are a set, but the set has the unfortunate problem that we can't override the hash function, so we can't just make it a set of a class, because the surface, we just can't do it. We could make a dictionary of strings to surface, and the string of a surface is basically just a concatenation of all the strings of the cubes. In that case, we can like remove it. The other option is we can do like a invalid bool equals false, and here we can guard not dot invalid else return false, and here we can do the same but with that and not false, and here we can also probably do the same, and here do we have like ternary operators? Samples control flow, we've got some ifs, that's all of them, is it? Right, yeah, I'm not sure we have ternary operators, so what we can do is have this guard and just return 0 EZ, and otherwise return dot edges like that, and do that. And maybe we can just set that as public, because here we will go join touching I, and then touching I.invalid equals true, because we join it to the other one. And maybe like to do it would be better if we just remove this from the surfaces array, but there is no remove function. Right, so that does it, I think, potentially. I mean, we haven't implemented this join, but we've implemented everything else. So what I might do is we can, not that one, we can run this and example like that. Right, so it doesn't know how to do a bunch of things. Edges missing type. We need a function on edges. Like here, function. What next? Cube it doesn't like. Yeah, all those ends we need to as bang. As bang I64, and maybe we'll copy to there and do that. Where do we get to? Here. Right, cubes.push throws. And where's that? 57? Alright, I will agree with that. So we can just throws there. I would imagine that would also need throws there. Touching dot push cube. We just want to push push the surface. Right, so we need to have this as surface to do that. So hits that overloaded one. Right, now it's compiling in C++. Oh yeah, we can't actually have yeah, this I think we need to yeah, we'll just do not there. Have a underscore in the private one. Maybe that will be easier. I don't even need it anymore. Yep, and so now if we do that, now it's compiling. And we get an answer. So that's kind of cool. What I might do is if we copy inputs day 18.example1 to, in fact, can we just go like that? No. Can we go like that? No. So, yeah, I think if we don't run it with anything, it only does the example input. ls input. So day 6 also has so test 6. Yeah, and that runs like a bunch, but 18 does not. And in our actual input, we are joining together surfaces. So we need to think about how to do that. But I would want to get the right answer there first, I guess. It's unsettling that it is not the right answer, I guess. Example 1 to input. Yeah, just that, and then build day 18. So it reckons 4 for this thing that should have 10. So what we probably want to do is print line in join this equals this, and we can just print out that print line touches a cube, and then here we can probably go this now equals this and do that, and maybe we can go build.sh day 18 and run that, because I want to run it just on that basic input. So here we have our join. So our first surface just has, maybe we can go there. So we just have 1 on 1. Edges is 0. That is not right. So that could be our problem. When we generate a cube, edges should be 6, because there should be 6 on it. Which would probably make it 10, which it's meant to be 10. So here we could probably run that test. That's printing out too much stuff now. I'm happy that does that. I'm happy that does that. I'm happy that does that. Now if we run that again, yeah, I don't know why. Oh, we need it to be 2 inputs day 8. Yeah, day 18 dot example, and I wonder if we can do something like that. don't think we can. But here we also want to go outputs and outputs here. Outputs. Now if we do this test, it should, yeah, so it does our 2 examples and now it fails on the actual input. So that we are going to be doing this joining a surface. So we've got, in fact, I wonder if we could print line surface joining surfaces print line this equals this and other equals, we're calling it surface, but I'll just print it out as other. And I think we can probably just run this. And here we've got a surface, so 10, 16, 14 and 11, 16, 14. So do they join? Yep, they join on the X. Edges should have 10, that's alright. So here our other is 11, 16, 13. So that is joining to that one. And it's only got 1 cube, so I guess, yeah, actually I'll just do it that naive way. What we can do is for C and dot surface dot cubes, and we can just call join with cube of C on this, and maybe we can surface dot invalid equals true. Yeah, that might do the trick. And then we can like kind of hide this. Actually, no, I'll keep it there because that kind of doesn't hide the dodginess. Right, I wonder what this shows me. 3396. I'm gonna try it. 3396. Can't push enter, but can click on that button, and it is a gold star. Cool. So what we can do is outputs day 18 dot output and part 1 and not that one. Get out of there and do that. And now if we run tests on 18, we should get pass. And it takes not very long, so that's pretty cool. Inputs, outputs, and day 18, and have a look at that again. And we'll commit that up. Day 18, part 1. Cool. It is good to get like a quick win, I guess. Just after need a chmod that, then push. Probably need to pull and push. No, I don't think we do. But shortly after that push, we'll need to do a pull. Cool. So that is that. We'll do part 2 in a different video. See how that goes. For now,